Hey guys, welcome to another awesome video. Naj Kazi here. Today's video is about software-defined networking, or SDN. I will give you a quick history of SDN. Then I'll address the question, why SDN? That's the key question. If you want to learn anything in IT, always ask why. We'll then talk about how and what. And finally, I'll give you some real-world examples of SDN. It's gonna be an exciting one today. Are you ready? Let's roll the intro. SDN demystified. That's what I'm gonna cover in today's video. HAL 9000, go check it out on Google. 2001, A Space Odyssey, and you'll figure out the reference made here. Here are the topics I plan on covering in today's video. Why, what, and how of SDN. And finally, some real-world use cases of SDN. Let's dig right in. There are 4 major challenges that most businesses are facing today. First, device explosion. Let's get into it. According to this report from Statista, there are roughly 4.5 billion people online, and we're talking active users. That's more than half the population on a global scale. You're looking at almost 60% of the global population online, actively using the internet. Another report from Statista, about 3.5 billion people are using smartphones as of 2020, and the number is expected to grow for obvious reasons. Here's a report from Security Today for IoT devices. In 2018, they were expecting total number of IoT installed devices globally to be at 7 billion. In 2020, we're looking at that number to be at 31 billion. That's more than threefold. That's more than 3x. So the growth is just absolutely exponential. And if you think about it, guys, most of us happen to have, on average, about 3 different devices that we carry. You know, we have a laptop, we have an iPhone or an Android, and then we have a tablet. So, you know, if you think about it from that perspective and you multiply it by the number of people on a global scale, you can see how fast things are exploding. And that's not to include the IoT devices, right? The smart watches and the smart thermometers and, you know, the different smart things that you can have. If you include those, I mean, each household has a ton of devices overall. The second major issue is the cost of human error. What do I mean by that? According to a McKinsey study performed back in 2016 for Cisco, McKinsey is a very reputable consulting firm, and according to them, most of the companies spend 3 times the amount of money on maintaining the operations of their network as compared to buying the network gear. What does that mean? For every $1 million you spend as a customer on buying network hardware, most likely you can end up spending $3 million on managing and operating the network. So, I mean, that's a really, really high cost of operating a network, and that is not cool for most of the businesses. Third, traditional networks lack end-to-end visibility. So here's an example. We got a bunch of different devices, right? So we got this Wi-Fi access point connecting into a switch that has a bunch of different devices connected to it, you know, a server, a Citrix NetScaler, a firewall, a storage array, and a router. And each of these devices most likely will have a separate GUI. If you're looking at a traditional network, it's going to have a separate dashboard that you're going to have to log into to be able to manage that device. And that is absolutely insane because That makes it really difficult to have a central view of the entire network. And to make things worse, you have to configure these devices hop by hop, and the ACLs and all the different rules that you specify on these devices have to be done separately, right? So if you fat-fingered something on any of these devices, it may compromise your entire network. So that's a big challenge. And as I alluded to, you have so many different dashboards, it could easily drive you crazy looking at all these different screens instead of having a single dashboard. All of these issues that we have talked about so far could easily lead to major security issues. According to the ZDNet report, most companies take over 6 months to detect a breach. Guys, that is absolutely insane if you think about it, right? So imagine there is a rogue and compromised laptop on your network, and one of your network admins fat-fingered an ACL on your firewall. And because you have no visibility into any of these things, a hacker can easily infiltrate your network and wreak havoc for months, damaging your business and brand. And the scariest part, you would be completely oblivious to it since you have zero visibility into all this. And at the end of the day, it could potentially mean game over for your business. So it's a very, very scary thing. That being said, now let's do a deep dive into the what and how of SDN. So let's address the what first. But before we get into SDN, I think it's very important that we first talk about a quick history lesson on virtualization, because it's an important aspect of software-defined networking. So a company called VMware started back in 1998 in sunny Palo Alto, California. Okay? And that completely revolutionized everything because VMware was the pioneer in the realm of compute virtualization. And in 1999, they launched their first product called Workstation 1.0, and it was an earth-shattering product. Right, you could install it on your machine, let's say a Windows operating system, and after installing that software, you could run multiple virtual machines on top of your laptop, and that was a game changer at the time. An absolutely earth-shattering technology. Now let's shift our attention to what does SDN stand for? Software-defined networking. As I like to call it, it's virtualization on steroids. And there are two fundamental tenets of SDN. Number one, the whole idea of SDN revolves around central intelligence. And then the second element is intent-based networking, or IBN. First, let's do a deep dive into central intelligence. So if we look at a traditional network, we have the data plane and control plane located on the same device. And let me explain what data plane and control plane is. Okay? So let's imagine you're sitting on your laptop and you want to send an email to your friend. You type up that email and you hit send. It goes through your Wi-Fi connectivity at home, which is your Wi-Fi access point. It ends up hitting your home router. Your home router is going to forward that email over to your ISP router. Your ISP router is going to talk to your friend's router. Your friend's router is going to talk to their Wi-Fi. Eventually, the email is going to make it to your friend's laptop or desktop. That's how the entire communication happens. This is where control plane and data plane comes in. There are two things that happen in this communication, guys, that I want you to pay attention to. One is the email itself. Okay, so that would be the data plane, right? The actual goal is to send an email. What happens in between on your network, you as a regular user could care less, right? But the way routers talk to each other, They talk to each other through a control plane. So now let me give you an official definition of a data plane. It's a little piece of software running on your router that is responsible for forwarding packets, whereas the data plane is a software that's responsible for allowing the network devices to talk to each other. That's their communication mechanism. And how to forward the packets. That's the next step, right? So if you have multiple paths to the outside world, which path should you choose as primary to communicate? Now let's talk a little bit more at a deeper level about the central intelligence concept. So as I mentioned earlier, on traditional network devices, we have the data plane and control plane located on the same device. But with central intelligence, what we do is we take the control plane and we put it on the controller. And what that means is the controller becomes the brains of the solution. Okay? So, and all these different nodes that are on the network, all of the network elements or the different network devices that you have, they are controlled and managed by this controller. And another way of looking at the controller is that it's an instructor that tells network nodes what to do. That's another function of the central intelligence. And what's cool about this whole thing is that because we're putting the control plane in the controller, what that means is now we don't have to touch all these routers at the bottom that just popped up separately, right? We don't have to touch them hop by hop and separately. What we can do is through a centralized controller, we can configure the entire fabric automatically. And that's the beauty of central intelligence. And the other concept, very important, is called intent-based networking. So with the intent-based networking, the whole idea is that you as a network operator define your intention to the network. The network controller takes that high-level intent and automatically translates it to low-level config details and enforce policies to produce a desired outcome. In this case, for example, we're saying add a new SD-WAN appliance to my network in San Jose. After we did that, the information will make it to the network controller. The network controller will then go, okay, here's the deal. If the serial number is authorized by the network operator, if it matches the SD-WAN appliance when it's added to the network, do the following. It's a large appliance. Based on the hardware and licensing information, apply the large site template with the following policies: routing policy, QoS policy, security policy, service chain policy. And it does all that. So as soon as you bring the SD-WAN appliance into the mix and you power it on and it calls home over your wide area network, it's going to talk to the controller, and the network controller is going to push the configuration down. All that happens you without touching the CLI or you as a network administrator doing anything. All you did was you defined the intent, a business intent, through a GUI portal, for example, and the controller did the rest for you. That's the beauty of IBN. So you can think of IBN as a very crude and rudimentary form of artificial intelligence. This is, in my opinion, a first step in the AI direction. And as the time progresses, I think we're going to see a lot of really amazing things happen in this arena. Now let's take a step back and once again ask the question, why did we need a controller to begin with? Or what are the benefits of a controller? To me, there are three big benefits. First, virtualization. SDN virtualizes the network. SDN separates network functions from the underlying hardware, and this is called NFV, or Network Function Virtualization. So in this example, we have an SD-WAN appliance, and on this appliance, we have the ability to be able to spin up a virtual firewall. a virtual router, a virtual switch. So as you can imagine, even though it's a single piece of hardware, but we have the ability now to virtualize it and add multiple different pieces of intelligent software to be able to allow this device to act as a multi-functioning device. These are also called VNFs, or virtual network functions. Number 2, automation. So what ends up happening, as I alluded to earlier, when we have an SDN appliance in our network or SD-WAN appliance in our network, it goes over the WAN, calls home, the network controller then pushes the configuration down, and the device is able to automatically configure itself. This is known as ZTP, or zero touch provisioning. This is a fancy term which basically means that you as an administrator, without having to touch the device, it was able to automatically configure itself. Now there's no magic behind it. We have to set up templates in advance for the device to be configured automatically. But the beauty is that we get to do all that in advance, and we can use templates and really simplify the way we configure and always expect the same results. So this dramatically speeds up the deployment of our network. And last but not least, visibility. So we get end-to-end visibility now because we have a single network controller. This central intelligence gives us the ability to be able to look at the entire network and be able to manage it, right? So we can configure, we can manage, we can monitor, do all those things. It's very, very powerful. And with that, now let's look into SDN architecture. So at the heart of it all, we've got ourselves a network controller. And what we have on top of the network controller are these business applications and different network services that the business runs. Right? So remember we talked about IBN, or intent-based networking. So here's where we define the intent of what we want the network to do. Right? Through, let's say as a network admin, you might log into a GUI portal and you might say, hey, I want to add a new SD-WAN node to my network. And the way the controller talks to the business applications is through northbound APIs using RESTful or Java APIs. And to take a step back, APIs are basically application programming interfaces. They're basically intermediary piece of software that allow two different software components to talk to each other. And at the bottom here, we got the network elements. We got routers and switches and firewalls and all that. And the way controller talks to those devices is through southbound APIs using protocols like OpenFlow or SNMP or Netcom. As you can see, the network controller is in charge of talking to everybody, but as the network admin, we are the ones that are defining what we want the network to do through the business application, and then the controller makes these API calls or requests down to the network elements and goes, hey, this is what the network admin wants me to do. Do you have the resources for us to make it happen? If not, what do we need to do? Do I need to spin up additional routing capacity or switching capacity or firewall capacity or server capacity? Depending on the type of capacity required. But network controller at that point is in charge of taking the business intent and then translating it into low-level technical details. And there's also this idea of east-west APIs on network controllers, right? So when we're designing networks, we never want to have a single point of failure. High availability is key in any network. And here in this design, if you only have a single network controller, that becomes a single point of failure, and that's bad. So to add resiliency to our network, what we do is we typically end up adding multiple controllers. In case our primary controller went down, we have other controllers that can take over, and that communication happens through east-west APIs. Taking a step back, what we have is three different types of layers that define the entire SDN architecture. The network elements at the bottom are called infrastructure layer. Controllers are part of the control layer, and the business applications are part of the application layer. And with that, let's now talk about a couple of SDN real-world use cases. So initially, when SDN came out, it was in the data center realm, right? So software-defined data center. That's where this technology took off. And then a couple of years ago, software-defined WAN became a big deal. Software-defined wide area network. And right now, all the companies globally that are looking to upgrade their WAN infrastructure are very seriously considering SD-WAN. And then came along the SD-LAN or SD campus or software-defined local area network. And here the idea is that our switches and our access points and all of those devices can now also be automated. And finally, SDX. So basically, that's an umbrella term for anything software-defined. Could be software-defined security, for example. The best non-technical, most simplistic analogy I can give you in real world would be your iPhone. If you have an iPhone and you got all these different apps on your iPhone, God forbid, if it falls down and you shatter it and the device is dead, now you hope to God that you actually had iCloud enabled, which is the Apple iCloud, right? So if you happen to have the iCloud enabled before you shattered your phone, what iCloud does is it takes all of your applications and it creates a replica of your phone's profile into the Apple iCloud. And then the iCloud, when you get a new iPhone back, which is a blank iPhone with nothing on it, but the minute you log in with your Apple ID credentials, it talks to the iCloud, and assuming that you had iCloud enabled before, it's going to go ahead and pull the configuration down on your new iPhone, and what you will have through magic, all of your applications show back up on your iPhone, and you'll be good to go. This is an example of decoupling data from the device. So it's stored in a central location, similar to how SDN operates with the central intelligence. And that wraps up today's video. Hope you guys enjoyed today's video. If you did, give me a thumbs up, hit subscribe, and I'll see you in the next video.